Okay, so question 3. Sketching the graph. I've got a strange thing where I've copied this, that there's a cursor there. So this shouldn't be there. That's just the modulus of 2x minus 7a. And they really like doing this, don't they? You know, most of the time that we practice doing modulus graphs, we've done it without an extra constant in. But throwing the constant in always makes life a little bit more difficult for people. This is a modulus graph with a positive gradient. A is a positive constant, so this would, if there was no modulus there, it would cross at minus 7a. So we've got a graph that is steep and symmetrical, and crosses at those 2 points. You got just 1 mark for drawing that shape of graph there. And then the second mark, it did say state the coordinates of the points where the graph meets the x-axis, each axis. This point here is where x would be, where y would be 0, so 2x would be 7a, so x would be 7a over 2. It did say state the coordinates, but I'll talk about that in a moment. This one would be if x is 0,
7a.
You would get 7a. And you had to mark both of those. Now, we're going to be really careful with this, aren't we? Because there have been times in the past where they've said coordinates and they've meant coordinates, so they've not allowed you to put just the value. They let you get away with it this year. If it was clear the point that you were going for, then they allowed you to omit the 0, as long as it was clear. You had to have both to get the second mark. Solve the inequality. 2x minus 7a, the modulus of that is less than 4a. Well, you know, we've talked about this, about 2 methods for doing this. I think the squaring it becomes slightly more complicated because you've got the a in there, although you can deal with it by squaring it. This would be a line that went across there somewhere. So we're looking at where does the positive branch cross it, and where does the negative branch cross it. They're the 2 points. This one would give us 2x is 11a, so x is 11 over 2a. I've just changed that, I went through, that's supposed to be an x. And this one would give us 2x minus 7a is negative 4a, so 2x is plus 3a, so x is 3 over 2a, and there we are. I've done it again. There would be the 2 values. Second part, or the final part of the question said, deduce the largest integer n satisfying the inequality 2 ln n minus.
Dave, do you not need to do part 2 with inequality? It says solve the inequality, or does it not matter?
Oh yeah, no, we've not finished yet, have we? So yes, you're right, they're the 2 values. So we needed to recognise which bit it was. It wasn't an equation, was it? I've copied it down on there. It was that we were doing. So when is it less than those 2 values? It's the point in between them. If 4a goes across there, it's the point in between those 2 solutions. So we've got, you're quite right. X looking at it. That's better, isn't it? The final part said, deduce the largest integer n that satisfies the inequality, the modulus of 2 ln n minus 10.5 is less than 6. So they want us to make a deduction in what's going on here. Let's see if we can spot the connections between things. As it's saying deduce, there must be a connection between that inequality and this one. Well, it looks to me like instead of 7a we've got 10.5, instead of 4a we've got 6. That means that a is 3 over 2. That works, doesn't it? 3 over 2 times 7 gives us the 10.5. So this is working with a as being 3 over 2. And instead of x, we've got ln n.
Did you get Mark right in that?
That's what we've ended up with. Well, I can't remember. yes, you get a mark for relating A equals 1.5. Well, hang on. But it had to lead to something. So it had to lead, because there's only 2 marks here, and that had to lead to a next statement.
If I put
And
the
that
3 over
next
2 where A
statement is that what we're doing with this. If we think about the values that this gives us that are significant, we've got ln n as being between the values 11 over 2a we've got that kind of statement. So we have to get somewhere from that. We're looking for the largest integer n, so we don't need to worry about the lower limit. We're really considering that as an inequality. Why have we put 11 over? Oh yeah, so a is 3 over 2. So 3 over 2 times that gives us another thing. Do we get that? 33 over 4, yeah, 16 and a half. So we're looking for the value of n that satisfies that, and it was 3827. If you do inverse, if you do e to the 33 over 4, you get 3827.6. So we get n less than 3827.6. Therefore, the largest n is 3827. Remember, the question said find the largest value of n that satisfies the inequality, and that was what we're doing with that. So it's not enough just to have a is 3 over 2 and x is ln n. It has to lead to ln n is less than 16 and a half.
So you have to have that for the first mark.
That's 16 and a half. Yeah, is that 16 and a half? 16 and a quarter. You have to have that.
Have to have the ln n for the first mark.
Yeah.
Oh. Alright.
Hang on, that's not the right value, is it? Is that right? Yeah, okay.